Excuse me. On behalf of the Tug Hill Commission, Region 6 of the New York State Department of Environmental Conservation, and the Hamilton, Herkimer, Jefferson, and Lewis County Soil and Water Conservation Districts, we're so happy you could be with us today for this virtual piece of the Black River Watershed Conference. This is the third of 7 webinars, which were originally planned for our in-person 10-year anniversary conference. We were really looking forward to that, and we really hope to hold that again in 2021, because we do miss you. The entire schedule of webinars is on the screen for you right now, and it's available on the Tug Hill Commission's website at www.tughill.org. A couple of housekeeping items. Today's webinar is being recorded and will be posted on the Commission's website when we're done, and you're all muted to reduce background noise. If you have questions, go ahead and drop them in the chat box, and we'll get to them when it's appropriate. Please try to keep your comments and questions focused on the Black River Watershed. I'd like to say hello to our panel members today. They are Nichelle Swisher. Do I have Katie on today? Thought I was going to have Katie. I have Nichelle Swisher from the Lewis County Soil and Water Conservation District, and Caitlin Stewart from the Hamilton County Soil and Water Conservation District. So thank you, ladies, for joining us. And Katie Malinowski is the Executive Director of the Tug Hill Commission. She's also one of our panelists. So our first speaker today is Jamie Parslow. Jamie is a district technician at the Hamilton County Soil and Water Conservation District. She received a BS from SWCD Environmental Science and Forestry in 2008, and since then has worked in the environmental field educating the public about important conservation issues. Jamie is going to talk to us today about the state of Hamilton County lakes, a 25-year perspective. And I should mention as well, there are supporting documents to Jamie's presentation on our website at www.tughill.org. So Jamie, take it away. I will stop sharing my screen. And
excellent. Perfect. Hello, everyone. I'm just going to share my screen. I apologize if there is any delays or anything. I'm going to try my best here. So let's see. Oh. Trying to get it. Okay, let's try now. So Jennifer, for some reason, it won't let me share, of course. It's coming up blank. Do I have permission?
You should. Let me try again. Oh, let's try this again. Yes, let's make you co-host.
Wonderful. Let's try.
Yep.
It is not, I swear it worked like a few minutes ago when we practiced.
It did.
See the share screen button at the bottom?
Yeah, I see that. It's coming up and it says basic, advanced, and files on the top. And the basic normally has the desktop thing, but none of that is coming up right now. I know. What? Of course. This is just so who can share, all panelists. Let me see. It won't let me. I don't know why.
Okay. Do you want to try sending the presentation to me and I'll share it?
We could try that. If I log out and log back in, I just don't understand. The presentation is rather large. I'm not sure if it will send over. There's that.
Jennifer, is Jamie listed as a panelist or as a host?
She is listed as a host.
Okay, so she should be able to share.
Let's see. Let me reclaim the host for a second here and then try to share her again. Okay. Nope. Thanks for bearing with us, everybody. Give us 1 second here.
Technology. It's
I know.
but it can definitely have its downfalls. So let me see. Meeting.
Okay, here, let me try it one more time. I'm going to make you a co-host. Yes. Did that work, Jamie?
No, it's still coming up blank on the basic share, and I'm not sure why. The share screen button on the bottom is bright green. I don't know if it's typically like that on anybody else's screen. Oh, yeah.
Okay. So let me read Catherine's introduction, and then we'll circle back around to Hamilton County. So our Katie Whitcomb and Bob Tilby are technicians at the Herkimer County Soil and Water Conservation District, who run the Japanese knotweed invasive species project for their county. They have worked for Herkimer for 3 and 2 years respectively, and are both New York State DEC pesticide technicians, allowing them to treat Japanese knotweed. They also run their district's Hydroseeding program, which is a soil conservation practice provided to towns and municipalities within their county. Okay, go ahead, take it away.
Okay, well, thank you, Jennifer, and everybody else for helping set up this webinar series. I'm happy to share. I'll start right in on our Japanese knotweed project. A couple of years ago, I attended the Black River Watershed Conference and did a similar presentation, but this one is kind of an update to that. So if you saw it then, you might remember a little bit of it. So we should start by saying, what even is Japanese knotweed, right? So it's an invasive species native to Asia, and it grows very quickly. It's considered to be a noxious plant because of how easily it spreads. And it looks like bamboo. So you might recognize it from these photos here. And it can grow up to 15 feet tall. Typically people see it along rivers and streams, roadsides and culverts. And I've even seen it growing quite prolifically along the railroad tracks or the canal. I'm a kayaker, so sometimes I see it in places that are unexpected. So Herkimer County Soil and Water Conservation District was awarded grant money to start a 3-phase project to work on eliminating Japanese knotweed from our county. So it was a 3-phase project that's ongoing, and the first 2 phases just included doing an inventory of all of the roads within the county, looking for stands of Japanese knotweed. And then phase 3 and on, which is where we are right now, is all the steps it takes to actually start treating this invasive species. Now it's kind of Japanese knotweed is a concern because it shades out native species, and it can cause soil erosion, and it's kind of like a recreational bummer, you know. So just to give you an idea of where Herkimer County is located within New York State, here's this map. We're kind of smack dab in the middle. And our survey was just a windshield survey. So we found all the knotweed that we could see from all the roads within the entire county. And then we took photos and notes that we put in binders. The first phase, we spent an entire summer inventorying all of the southern portion of the county, which was over 1,500 miles of roads that we traveled, and we found over 500 infested sites of Japanese knotweed. Phase 2 was the whole rest of the county. another 2,600 miles, almost another 500 sites we found and documented. And during phase 2, we also started doing some more outreach to educate the public and municipalities. And Jen, I'm going to have my first question, true false question, since we're talking about outreach materials. So true or false, mowing and cutting Japanese knotweed is an effective method for eradicating it. So I'll give everybody a minute or so to answer that. We have landowners that have come into our office over the years asking of all sorts of different ways to treat and get rid of their Japanese knotweed. So I'm interested to see what you all think. Looks like half have already answered.
Yep, and they've all got it right.
Yeah, everybody got it right. So part of our education and outreach that I'll include in this next slide. Do I just close out of this, Jen?
Yep.
Okay. Let's see. Okay, so this is some of the outreach material that we developed for municipalities and just landowners in general. And a big point that we tried to get across in this was that mowing and cutting Japanese knotweed is not an effective method to get rid of it. In fact, it really exacerbates the problem because small pieces of Japanese knotweed can break off from the stem, from a branch, and even really teeny tiny pieces of the root. If any of those break off and are carried to another location, they can sprout whole new plants and cause new infestations and just really make it worse. Phase 3 is, like I said before, what we're doing now, and it mainly includes prioritizing the infested sites. Since there's over 1,000 sites, we really do have to prioritize our work here. And both Bob and myself obtained pesticide technician certifications, allowing us to actually treat the knotweed, and we've already begun some of our treatment. Now this map over on the right side is just a screenshot that I took that shows all of the, all of the sites in Herkimer County and surrounding counties that were inventoried by us and anyone else who has an IMAP Invasives account. IMAP Invasives is actually a really great tool that anyone can use. We just decided to partner with some of the prisons to do this. It makes the information publicly available and it's just a good way to track it. So if you think you see an invasive species, you can always use this resource as well. This is just showing, here's Bob in the top here, collecting GPS data and measuring the size of one of our stands, and just what our paperwork looked like while we were doing our inventory, and the binders that we keep all that information in. These are just a couple screenshots from our IMAP Invasives entries, just to give you an idea of how we had to upload everything. And this is actually how the site used to look. It's more up to date now. Here is, I put this map together just to show you where within Herkimer County the Black River Watershed lays, which is basically this area here. And then we put this map up together that shows all the confirmed sites of Japanese knotweed that we found in our inventory that are located within the Black River Watershed. And you can see really it's got a fairly low impact in the Black River Watershed so far, at least within Herkimer County. And the sites are concentrated around Old Forge, which is obviously a more populated and more traveled area. And I will go to my poll question for everybody. See how much everybody was paying attention. Which of these is not an adverse impact of Japanese knotweed infestation? It's kind of fun to watch everybody do their voting. So it looks like maybe almost a third of everybody's gone so far. Almost everybody was right. Increased biodiversity is not an adverse impact of Japanese knotweed. it really actually decreases biodiversity by shading out the native plant species in an area. And in doing so, it also increases erosion because those native plant species from the lower understory will die out and release their roots from the soil, causing more runoff into streams. Okay. So a very important part of our project was, needing to prioritize these sites. Having over 1,000 sites and only 2 of us able to treat them sort of seems like a very daunting task. So we went through all of our binders and notes and picked out sites that looked like they were on blue line and trout streams. So anything, water quality bases are number 1. And then we obtain board approval from our board of directors and have them sign off on a specific list that we are going to prioritize to treat first. Now, this is also based on our ability to receive permission from all the landowners, and sometimes that can be difficult. We have some high priority sites that we just can't get a hold of the landowner to have them sign our agreement that allows us to access their property to treat it. And just another note, when we originally did our inventory, some of our GPS points that we used to save a specific location were kind of inaccurate. So we recently purchased a GPS Trimble unit, and Bob's going to talk a little bit about that later, but that really helps us make our priorities more accurate. Now on to the fun stuff, some progress. Bob and myself took 2 DEC certification exams and became certified to start treating. And like I said, we had to prioritize some of the sites. We had to purchase all of the equipment and PPE to keep ourselves safe from the pesticides that we use. And we were lucky enough to partner with Hamilton County. Lenny Crew, one of their technicians, is also a certified applicator, and he allowed us to treat under him so that we could gain some experience and get a handle on what we were really doing. Our first year was 2019 of us treating, and we were able to hit 15 sites within Herkimer and Hamilton counties. This year we had less sites hit, but more towns. We covered more area of the county. This top picture here is just kind of a small shot of what it looks like after knotweed's been cut, and then it starts to grow up. You can actually see that it looks like there's way more shoots coming off of these. And then this lower picture here is Bob retreating. I think almost every single picture has Bob in it. Some more progress photos. The picture on the left here is before we ever treated this site at all. It was, it's located above the banks of the Black Creek, and so that's why that was a priority to us. And the second picture here is after just one treatment the following year. You come back and you can see that, all of this is dead knotweed, and then just like this little regrowth here. And when you get up close, you can see there's just very small plants like this on the bottom right corner. So we felt that that was pretty stark difference and nice to see our progress. We also prioritized more sites within Herkimer County, specifically the northern portion of the county, because there's just less Japanese knotweed up there right now. And so it should be nice to keep it that way. This year, we were also lucky enough to get a good partnership going with the county highway department. And we asked them to tell us what they thought were priority sites. And they had a number that were really just hazardous sites where the Japanese knotweed is growing over the roadsides. You can see there's really no shoulder here at all. And if this was allowed to get bigger, it could completely blind a driver coming around a blind turn. So they know that cutting it for visual purposes is just making the situation worse. So we were able to treat these sites this year. And I don't think I have a picture of it, but we did have a lot of success, especially in this area here. Here's a couple more progress pictures. This top right picture is 2019 before we treated it all. And it's kind of hard to tell, but in this lower picture here, this area is not Japanese knotweed anymore. And this is this year after 1 month after we retreated. So this was the full stand with no treatment. This is after 1 season of treatment. We really kind of hit the back side of this. And you can see that there's a little bit of a difference. And then this was after 2020's treatment. And I mean, wow, what a difference. So we're really hoping that next year there's minimal regrowth. This is the same stand, but the back side of it. And we prioritize this because of the water here. This is a trout stream. And right in the top right here is the before picture from 2019 before we did any treatment. And then down here you can see our success of injection in 2019, how it looked this year when we came back to visit it. And I'll point out that we use injection mainly for all of our treatment because it's the most successful that we know of. And I'm going to ask you all a question. Please send your responses in the chat box, and I'm going to ask Jennifer to tell me what you're saying, and maybe I can see it, but I'm not sure what I'm doing here. How long do you think it takes to fully eradicate a single stand of Japanese knotweed? So go ahead and type that in the chat box. I have no idea how to check that.
That's all right. I'm watching for you.
Okay, thanks.
Can you ask your question one more time?
Yeah, no problem. So how long do you think that it takes to fully eradicate a single stand of Japanese knotweed?
Okay, you've got 3, 4 responses. And they're looking like 3 years, 3 years, 3 years, 3 to 4 years, 4 years, 5 years, 2 years. Sue Guai says 3 years.
Okay, well, I think they're all pretty good guesses, you guys. Thank you for putting in what what your guess was. It really depends on a lot of different factors. The type of application is a really big factor. You could do foliar application. Some people do cuttings and different things like that. But we really find that injecting is the very most effective treatment method, at least in our experience. So that will cut down on the length of time it takes to get rid of a stand. The size of the infestation also matters because by DEC, you're only allowed to use so much herbicide per acre per location. So this right here, the reason that we didn't treat this entire stand, sorry, this one here, in that first season was because we used as much of the herbicide as we were allowed to by DEC. So we had to wait until this year to be able to treat the rest of it for just the first time. And also the success of our efforts. Maybe one stand is especially difficult to knock down and it might come back strong still. So we really figure probably between 5 and 10 years really to fully eradicate one stand of Japanese knotweed. But there are a lot of factors, so hopefully 3 years can be true. Okay, now I just want to talk a little bit about how we actually physically do the treating of the Japanese knotweed. So the best action we can take is to inject each and every stalk in a stand. And that can involve a lot of crawling around on the ground in between large bamboo-like structures. So each gun dose, they're like a little injector guns that we use, is 2 milliliter doses, but we like to give each stalk 4, so it's a double trigger in each and every stalk while we're crawling around on the ground. And then we actually also use foliar application. You can see Bob over here with our sprayer, and that's just for any plants that are too small to inject because it's just not as effective. And we like to keep any herbicides out of the environment as well as possible, which would be by injecting instead of spraying. Already talked about how much pesticide we're allowed to use per location. And Our treatment season is really limited. First of all, we have multiple different programs that happen all in the same little short season, like a hydroseeding program that Bob's going to talk about in a little bit. And we have to wait until the Japanese knotweed starts flowering. And this year it didn't seem to even start until maybe the first week in August, or maybe even a little later in some parts of the county. And then we can only go until the first hard frost hits. And everybody who lives or has been in upstate New York knows that that's totally variable. You never know when the first frost is going to hit. This year it was pretty early. So here you can see Bob actually injecting. I have a better picture of the gun a little later. And so this is what we do to each and every stalk. And then we also mark every stalk with paint markers so that we know where we've been. When you're crawling around in a stand, it's hard sometimes to know if you've already hit some stalks or not. So our total goal here is to eradicate all of the high priority sites within the county and promote native species growth. We understand that having over 1,000 sites and only 2 technicians, we just really need to focus on the high priority locations. It'd be years and years and years, maybe decades to get all of it gone. But I also want to point out that the Black River Watershed is a priority for us, and we plan to continue prioritizing that area of the county for treatment because there's limited impacts there so far, and we'd really like to keep that area more pristine to maintain and improve the species diversity in the watershed. And no project would be complete without some challenges. So I'll talk a little bit about that, but I just wanted to show you guys what this injector gun looks like down here. This is like a more expensive version because we have so much to treat, but there are more affordable options. So some of our challenges are that the municipalities are still mowing and cutting along the roadsides, but they have to for safety reasons. So, you know, we're still trying to help educate and work on those problems, but it is continuously challenging when it's always being exacerbated. It's also spread via fill materials. So when your neighbor puts in a new driveway and has fill put in, it might have little pieces of knotweed that nobody knew about, and then that grows and then it gets mowed, and next thing you know, it's in all of your neighbors' yards. We are working with the counties and towns to treat all of the right-of-ways, but it's sometimes very hard to get in contact with the landowners. That really has been a block for us. And because full eradication of each site can take 5 to 10 years, and the length of time it takes us to treat one individual site just in one given treatment season just really lengthens everything. So I really try to encourage landowners to treat Japanese knotweed correctly themselves. You wouldn't believe some of the things I've heard people suggest that they have tried or would like to try with their Japanese knotweed infestations. And I just try to educate them on the right way to do it and give them the contact information for the pesticide office at the DEC, where they could purchase their own injector gun. And to try to really keep them involved, I ask them to keep the district informed on how their progress goes so that, you know, it's just keeping them involved a little bit more. A great resource is knotweed.org. I believe Caitlin Stewart from Hamilton County's had a lot to do with putting that website together, and I gotta say it's just a really wonderful resource from people to contact, what to do, what it looks like, how to really identify the plant. So I recommend, if you have any further interest, to go there. And if you're interested in treating knotweed that you might have, I suggest getting a hold of the DEC. This is the phone number for the pesticide reporting and that website. And I could take a couple of questions if Jen wanted, if there were any in the chat box that Jennifer wanted to tell me about, but I think we could hold the bulk of them to the end of Bob's presentation, just so we don't take up too much time.
Certainly. We had one a question about replanting the areas. Is there a need, or should those areas be replanted?
Yeah, so we're going to go back. So I'm assuming that you're referencing like this. Yeah. Probably clicked too many times. Sorry about that.
Yeah.
So these dead stalks over here, we recommend that people wait until they look completely dead like this to try to get rid of them at all, to cut them down and remove them, because there's going to be small regrowth in there, and that small regrowth can still spread Japanese knotweed all over again. So eventually, you know, after a couple of treatment seasons, so a couple of years, then I would recommend planting. But I wouldn't do it immediately, not until everything's really been treated, because we are using herbicides to treat that, to get rid of it. So it might affect whatever you want to replant.
Gotcha. And one other, I don't know if this is a quick one or not, but Nichelle wanted to know about the average cost of the treatment per square foot, per unit, per area.
Well, that's a really good question. And I can tell you, I don't have a straight answer for that. We do use grant funds. Really, our biggest expense are the equipment we use, the guns and the backpacks that we use to inject. Each system costs about $700, I think, and we have 3 of them right now and have to get replacement parts as we go. And we probably, yeah, it depends on the density of the stand and how expensive it would be to treat, I guess.
What are you using to inject? What's the herbicide? Sue Wise would like to know.
It's called Accord XRT2, and that's just the one that we're using. It's the main ingredient is glyphosate that is used to treat the knotweed. It really is one of the only things that knocks it down.
All right, great. All right, so in the interests of moving on to Bob's presentation, I think we've answered them all. If not, drop a chat and we'll continue with Bob. Thank you very much, Catherine.
Yes, thank you.
You're muted, Bob.
Thank you, Jennifer. I'm going to see if I can get my presentation up. Perfect. Let's see. Is everybody able to see that?
I'm not seeing it. Hold on, let's see. Are you joining through the app or through the web?
I have a pop-up that said advanced sharing options, who can share. When I went to click the share screen, let's see here.
Just click the
Okay. Aha. Share.
There we go. Teamwork.
That's working.
Yay.
Beautiful. Thank you.
Yeah.
Alrighty, so I'm going to give a brief overview on our hydroseeding program at Herkimer County Soil and Water Conservation District. So if anybody doesn't know, what exactly is hydroseeding? Hydroseeding is a type of seeding process that uses a machine to spray slurry mix, that includes water, seed, mulch, and sometimes other soil amendments such as fertilizers to spray over an area to establish vegetation. Why would somebody hydroseed? This method is typically used over other methods when other methods can't be used, such as on steep slopes or within roadside ditches or confined areas. So the purpose of our hydroseeding program is to preserve and ultimately improve the quality of our water resources in Herkimer County. How might this be accomplished? So this is accomplished through hydroseeding by stabilizing the bare soil through establishing vegetation with the root systems. This will reduce erosion, reduce sedimentation, and even can reduce roadside ditch and culvert maintenance. So this service we provide to towns and municipalities at no cost to seed municipal owned property and rights of way. We try to get this out to them as in many ways as possible, so that way they can take advantage of this. Private property hydroseeding inquiries do come into our office on occasion. That's not our primary goal, but if we do, they're handled on a case-by-case basis based on water quality concerns. So the hydroseeding process, what materials might you need, do you need to hydroseed? Many of the same materials as other seeding methods. You need the seed, you need fertilizer when it's appropriate, some form of mulch. With a hydroseeder, there's specific hydraulic mulch that is a compressed bale of either wood fiber, paper fiber, or a blend of both. And in hydroseeding, you also use a tackifier that it acts like a glue, which holds the seed and mulch in place. Since many of the seedings take place on slopes, it prevents them from sliding down to the bottom during rain events. So the actual machine itself, the one that we purchased was a Finn T60 trailer mounted hydroseeder that we tow behind a 1-ton pickup truck. This hydroseeder has a 600-gallon capacity and can seed up to 7,000 square feet of bare soil. There's 2 different methods to spray out of. There's a tower on the back of it that is kind of like using a water gun at a water park. And then there's also 150 feet of hose that you can use as well to seed. So our program specifically, it started in 2017 with the purchase of that hydroseeder, as well as hiring a part-time seasonal technician to run the program. Outreach was made to towns and municipalities by contacting them through mail, phone, email. We've sent out, we've put articles in newsletters, as much outreach as possible to introduce the program and get as many towns and municipalities coming to us with sites to be seeded, which are usually roadside ditches. In the first season, the district staff hydroseeded more than 227,000 square feet of bare soil. So since 2018, a full-time district technician, who is myself, was hired in July to run this program, as well as assist with other aspects of district business. I do the same thing. I reach out to towns and municipalities to remind them of the service that we have so they can take full advantage of it. And this year specifically, we've been working a lot with the county highway department, as they've been very busy and haven't been able to hydroseed themselves. We've been providing that service to them on disturbed areas from their projects. And these take place within the right of way. So the process on how to actually hydroseed a site, where it all starts. It all starts with making that contact, whether it's a town, municipality, county highway department. They let us know that here's a project that we're going to be doing or we have done that we would like seeded. So we'll go out there and measure the site, take before photos of the site. When we measure, that's how we get our calculations to know how much material we need and how many loads it'll take to complete that site. Then we schedule the seeding and schedule traffic control if it's appropriate. And after the site is seeded, we take photo documentation through the seeding process as well. And then later on, after we've seeded it, we'll go back to see if it was a successful seeding and the seed established, and we'll take more photos. So, absolutely. So one way that we've been dabbling in measuring sites and keeping track of what we've seeded is a Trimble GPS unit. We recently acquired this, and what it does is it uses satellites to take your GPS location, and it's much more accurate than the cell phone that was used to inventory the knotweed sites. And the neat thing about this unit, you can measure area on it, so you can do a tract and enclose it and you can calculate area right off of that machine, and then we'll upload the data to GIS where we can overlay it on different maps. This does lead us to our first poll question. If you could help me out with that, Jennifer. The question is, how long does it take for a seeding to germinate? I'm curious what most people think. 2 to 3 days, 2 to 3 weeks, 6 to 8 weeks, or 2 to 3 months. And then after we have a few answers, I'll let you know what we have found.
Okay, they're coming in now, Bob.
Yes, they are.
Okay.
Yeah, it is. We have answers in all spots. So about half of you have answered, and about 40% of those who did answer said 2 to 3 weeks. That is what we tend to find with average conditions. It takes about 2 to 3 weeks for a seed to establish, from what we've found, and that's quite variable. It depends on the site conditions, the weather, the amount of rainfall. There's a site that I'll show you later that established in, I think it was probably about 10 days or less, but usually we find about 2 to 3 weeks. Let's see. There we go. Thank you. So here's a table of our annual results from the time we started our hydroseeding program. We've kept track of how many sites we've seeded and in how many towns. We've also kept track of how many loads we seeded in a year, in a season, as well as the amount of bare soil, the area of bare soil that we've covered in acres and in square feet. So in 2017, we had quite a high number at 227,000 square feet. And then in 2018 and 2019, those numbers were quite a bit lower, and we're slowly picking back up. And then this season in 2020, we had over 276,000 square feet that we were able to cover. And so I'll ask you this question in the chat. Why do you think there was an increase in the amount of area seeded in 2020 compared to previous years? Let's see. Not sure if I'll be able to see the chat. I haven't quite figured that part out.
Awareness of program is one.
Oh, yep, absolutely. So to be honest, many factors are involved, such as, that was a great point, awareness of the program. I now have highway superintendents calling me with sites rather than me reaching out to them. Funding transitions is an interesting answer. That could have certainly been a possibility. That hasn't been a restriction for us, but the main factor this year in particular was we had such a supply of sites to seed. We honestly couldn't even get to all of them this year, and that was due to our increased relationship with the county highway department. Like I said, they were very busy this year, and there were a lot of sites they weren't able to hydroseed themselves, so they asked us to do so. And that is what happened. Many of those sites were county highway sites. And this is just, I wanted a better visual of the amount of area that we've seeded each year, as well as which is shown by the orange line, and the green line shows our cumulative area in square feet that we've seeded since the start of our program. That brings us to over 900,000 square feet. So this is the Black River Watershed Conference webinar. Let's talk about some hydroseeding in the Black River Watershed. We've seeded in the town of Webb at 4 different sites in particular. It's this first picture is from Joy Tract Road in Old Forge. There's the Macaulay Mountain Scenic Chairlift sign. Many of you may have driven past that. This is at the intersection of Russell Street and Moose River Trail, right in Old Forge. We hydroseeded that in 2019. And then this one was done this year. This is the site I mentioned earlier that established in about 7 to 10 days. This is on the bank of Park Ave by the ball field. I believe the Town of Webb building and possibly the DMV is right across the street. I think that's what that building was. There were many factors to this that contributed to the speed at which the seed was established. The town highway department, they came in and put topsoil over the disturbed area, and then they raked it so it had an excellent seed bed. They even set a sprinkler out to water the seed. So many things were done in addition to just driving by, seeding the ditch and letting it go. So this one was an exceptional site, and I think we came back maybe 3 or 4 weeks and they were already mowing it. So we also, I mentioned a little bit about seeding on private property. That's not something we regularly do, but we handle it case by case, and it is all dependent on water quality, because that is our purpose, is to improve and preserve water quality. So this one we did deem feasible to hydroseed. This is at YMCA Camp Gorham, a nonprofit, and all of their disturbed area was located near a body of water, which many of the area was sloped towards the body of water, which could potentially cause erosion during rain events and end up in the water. So that leads me to my last poll question. And does anybody know what body of water is at Camp Gorham? We'll wait a minute to get a few answers in and see if anybody has an idea. I got to be honest, before I was up there, I did not know myself, so. All right, looks like about 1/3 of you have answered, and the actual body of water is Dart Lake. That is the body of water at Camp Gorham. So I'll just show you another photo of all of the disturbed area that we had seeded at Camp Gorham. This is on our way out after we had seeded 8 loads there, I believe. It was over an acre of bare soil. So that's an overview of our hydroseeding program, and I hope you found it somewhat informative and helpful in thinking about the Black River watershed and what we can do to preserve water quality. Now is a great time. If you have any questions, feel free to ask. Even if you have knotweed questions, we can go back to knotweed.
Great job, you guys. We often see, when hydroseeding's been done, but a lot of curiosity about what goes behind it. There is a question, a question from Steve Blockland. What percentage of the seeding doesn't take? Is there?
So yeah, I haven't actually done any success rate percentages, especially this year I haven't, but I think when I was doing it previously, sometimes we'd see in the 70 to 90% success rate. Yeah, I know that's kind of a large range, but trying to remember off the top of my head. One thing we noticed this year is we were driving around today actually, and interesting thing is a lot of our sites that were south facing slopes this year did not establish well, and we were trying to wonder if we were contributing that to the more direct sunlight and the lack of precipitation during that specific time that we had seeded it.
Interesting.
So it can be quite variable, but many of them are successful.
Okay. And then a question from Richard Waite. Does the highway department compensate you for the hydroseeding?
No, so the highway department does not. Towns, municipalities, If it's on municipal owned property or right of ways, we do not charge them if it is part of our program. It even includes materials. A case-by-case scenario, if a town comes to us and they might have a project that spilled over onto private property, then that's where we get into where we may have to charge the cost of materials for that seeding, things like that. But that's all very case-by-case dependent.
Okay.
Our grant funding
Yes.
is just to better the water quality of the entire county. So we can argue that it would cover anything for the municipalities.
Yes.
Can you repeat that? I didn't hear her.
Oh, so the funding source for our hydroseeding program is to improve water quality. So we're able to argue the fact that that can all be contributed and counted towards improving water quality.
Gotcha. And is there a different slurry mix for different sites or conditions?
Yeah, so actually I've used different things. There's different seeding rates, or one, if it's a very steep slope, I will try to actually reduce the seed rates and then double the mulch. So that way there's more mulch on the bed. And then I'll also include tackifier, which you can include in different quantities. So yeah, it's quite variable. You can use different seed mixes. We tend to stick with one specific seed mix that is for sloped soil. Yeah. All
right. So if there are no more questions for the folks in Herkimer County, let's try to loop back to the Hamilton County folks and see if we can, we're almost to 4 o'clock, but I think we could give them a little time to see if we can get their presentation going. Hi, Caitlin. And thank you to Bob and Catherine for jumping in there.
Excellent. All right. So hopefully this works now. If it doesn't, we kind of have a little bit of a plan B Caitlin's going to share. So bear with us. I really appreciate it. These times, I think we all get frustrated with technology a little bit. Oh. So it's still coming up that I can't share my screen, and I don't know why, because it worked this morning.
Jamie, when you're clicking,
Yep.
sorry, when you're clicking share screen, you're not choosing that little arrow, right? You're clicking in the middle of that screen.
No, I'm clicking in the middle, and it comes up where it should be like share your computer screen, share your files or something, but it's just a blank. It's not allowing me to share anything. I could go to advanced and it says slide as virtual background, all of that sort of stuff. But it looks like Caitlin was able to share from her computer, so we'll do it that way. Kind of thrown off my game here. It's a little interesting. So, all right. Can everybody see everything okay? Yes, okay.
It looks great.
Perfect. And Caitlin, I'll just tell you to switch that slides when we're ready. And I won't be able to point anything out with my mouse, so I apologize for that. So without further ado, my name is Jamie Parslow. I'm a district technician with the Hamilton County Soil and Water Conservation District, and I am going to try to present today about the state of Hamilton County lakes. It's a 25+ year perspective. All right, switch slides. All right, so the objectives of my presentation today is to just provide a historical perspective on the Hamilton County Lake Monitoring Program. We'll briefly discuss past and present water quality issues of Hamilton County lakes, and then we would hope to signify the importance of our long-term lake monitoring program and the significance of the 25-year report. All right, perfect. So for those of you who aren't familiar with Hamilton County, we are located fully within the blue line. We have 6 major watersheds within our county. One of those is the Black River Watershed. Hamilton County is home to probably over 385 lakes, and a majority of the land in our county is almost exclusively forested. 67% of that is state-owned. We're the least populous county in New York State, and like many other Adirondack counties and towns, we rely heavily on tourism and recreation to stimulate our economy. So with all of that being said, why do we monitor our lakes? It seems like we should have pretty good water quality without any major agricultural operations or any major developments. Move forward, Caitlin. All right, so there are a few main reasons why we monitor Hamilton County, why we monitor the waters of Hamilton County. The first one is pretty much human demand on water. You know, our freshwater resources are incredibly stressed. People use it for drinking, cooking, washing. Industry is a huge thing, especially in the Black River watershed with the hydroelectrical projects that they have further downstream from us. And recreation, people come into our county, in the Adirondacks in general, to recreate. They rely on that fresh water. Another reason why we do it is because biologically speaking, many organisms live in the water. They call fresh water their home, and the ones that don't are primarily made up of a lot of water. You know, water's important for all of us essentially. And probably the biggest reason for monitoring the waters is because humans significantly impact water quality. Everything that we do on land has the possibility to either hurt or improve our water quality. So large lakeshore developments, farming operations, anything that we're doing really does have an impact on that. And because we rely so heavily on recreation and tourism, maintaining the integrity of freshwater resources is of the utmost importance to us in Hamilton County, and I'm sure everywhere in the Black River watershed. All right, so early water quality issues, and these aren't just Hamilton County problems. These are statewide and probably even countrywide for a while. So one of the biggest things was cultural eutrophication, and that is essentially just the flux of nutrients from human activity that are being introduced into a watershed, and that speeds up the natural eutrophication process. So this was fueled by faulty septic systems, phosphorus-laden detergents. There's tons of runoff from farming operations, and this started, you know, the whole Great Lakes region really had major issues with this. Lake Ontario, Lake Erie had some pretty awful water quality back in the 1960s, 70s, throughout that time. And then another water quality issue that we hear a lot about is acid rain, and that impacted more than just our county as well. So pretty much in the 1950s, coal plants were releasing tons of sulfuric diacid and nitrogen oxides into the atmosphere, which essentially turns clouds and rain or any sort of precipitation into acidic rainfall. It was pretty toxic. And this became a major environmental phenomenon by the 1970s and 80s. We were seeing impacts of this all over the place. All right, so now I'm going to talk briefly about the history of the Hamilton County Water Monitoring Program. So this initially was a two-part program that was run by Hamilton County. The Soil and Water District didn't take over implementation or administration of this program until later on, but we were still partners with the county. So with the two-part program, they did chemical and biological analysis of water quality. I believe they started with 4 local lakes, and what they were doing there is they were testing for phosphorus, nitrogen, and then all sorts of bacteria, because in the early 70s, this is when their septic systems were really not updated, and there was lots of improper discharges and stuff like that. And then the second part of the program, which was probably the most impactful, was the sanitary survey program. And with that, they had inspectors that would go house to house and camp to camp to inspect septic systems and basically ask homeowners or property owners what their septic systems were like. As you could see from this picture over here, and I wish I could point at it, they asked a lot of questions about like, well, where is your, you know, what kind of detergents do you use and all of that sort of stuff. And through reading these historical reports, I found out that, you know, I think it says 87% of households that were interviewed used phosphorus-rich detergent. And then even after phosphorus was banned from New York State detergents, many property owners came from out of state because they had camps up here and they were still bringing that phosphorus-laden detergent. So there was lots of really interesting information from that. The sanitary survey program also performed dye tests and helped people fix the problems that they had. So this program was great education and outreach, you know, regarding proper maintenance for septic systems and what happens when nutrients pollute our freshwater resources. But at the same time, this program had pretty poor data retention. You know, we had the potential to have data from 1972, but many years of that data have been lost, and the program went through lots of administration changes throughout the years. So then finally, in 1993, an agreement was signed with the Hamilton County Board of Supervisors for the district to assume the administration and implementation of the water monitoring program. And really the main purpose of this program was to collect and record data over an extended period of time and to keep an eye out for watchful changes. So this is when our data set officially started. We were able to compile all the data in one place and really make sure that we were maintaining the integrity of data for that. All right, so we're gonna introduce our current day program. We monitor 21 lakes throughout Hamilton County. The lakes that are highlighted in the light blue there are the lakes that are part of the Black River Watershed. So that's pretty much the chain of lakes in Limekiln Lake. All of the lakes that we monitor they range in size and status, and they're pretty much all over Hamilton County. All right, so a quick overview of what we do. So we collect water samples once a month, June through September. We use that Herkimer sampler over there and grab a discrete sample from about 1.5 meters down, and those get sent off to a lab. But while we're out there, we also collect important profile data, and we use a handheld YSI Pro DSS device. It's essentially a little computer, and it allows us to measure temperature, dissolved oxygen, conductivity, pH, and a whole bunch of other really cool stuff. All right, so I'm just going to touch really quickly on what the profiles can tell us. They're really interesting, and I'm very sorry that these graphs didn't translate well into the PDF form. I promise you they did not look like that in the PowerPoint. So what you're looking at here are two separate profiles from two different lakes. So there's Fourth Lake and Seventh Lake, and these were taken this year. And I just wanted to point out the sort of data that profiles tell us. So if you look at Fourth Lake, we could see that the lake is, you know, stratified, which means that there's three distinct layers of water. There's the top layer, the middle layer, which is the metalimnion, that hosts the thermocline, and then the hypolimnion. If you look to the right of that, you'll notice a dissolved oxygen profile, and that kind of follows the same line as the temperature profile. So that's the dissolved oxygen profile of it. You could see oxygen decreases as we hit the metalimnion and thermocline, which is pretty common in Adirondack lakes. If you look next to it though, Seventh Lake is also stratified, but they have a completely different dissolved oxygen profile. Their oxygen actually increases at the metalimnion, which is interesting. It could tell us that there could be an algal plate floating right there, producing a little more oxygen in the water. So that's just some of the data that we collect from the profile. We don't really do any historical stuff with it, but there's definitely things that we could do in the future with all of this data. All right, so now we're going to talk a little bit about the water quality, the physical and chemical data that we're collecting and sending to the lab. So that water that we collect with the Herkimer bottle gets analyzed for total phosphorus, nitrates, calcium, aluminum, pH, alkalinity, and sodium and chloride. And we have to send all of our samples to an environmentally certified lab. So it goes to ALS in Rochester. And prior to that, we were sending all of our samples to Paul Smith College AWI lab for analysis. All right, so what does this 25 years of data tell us? You know, we've had a lot of help from our friends with interpreting this data. In 1993 to 2003, Cedar Eden Environmental analyzed the data for us in this 10-year report and gave us some pretty interesting facts about the trends we were seeing. And then again in 2017, we were able to contract with Paul Smith College AWI to do our 25-year perspective. A bulk of the following slides will show the results and the findings of that 25-year report. So these were some of the main things that we were looking at due to the historical water quality problems that we've had, so the acid rain and the cultural eutrophication. So we analyzed the pH and alkalinity. pH essentially is just a measurement of acidity, and alkalinity is the capacity of water to resist changes in pH. So when acid rain was falling, if a lake had good alkalinity, it could buffer that acid, and a lot of those impacts weren't felt. And you could see some of the parameters on the side. So this matters that we know what this is doing because, you could go down, Caitlin, because of acid rain. You know, we talked about that a little bit earlier, but acid rain had many ecological impacts. You know, it poisoned our lakes, it killed fish and other aquatic species. You could see all those dead trees right there. As the acidic rain was falling, it could leach aluminum and other minerals from soils, and then that accumulated and ran off into streams and lakes. And this was very toxic and harmful to many plant and animal species. And a lot of our lakes in the Adirondacks were impacted by acid rain. So this next slide again is just going to show you some variation in alkalinity throughout our study area. And again, I do apologize for how these graphs came out. It's not ideal in the PDF form. So if you look, Seventh Lake has pretty high alkalinity. I mean, I wouldn't call it high, but it's definitely higher than Limekiln Lake. And these two lakes are fairly close to each other. And it just goes to show how much of a difference the bedrock geology makes. So Seventh Lake definitely has a higher acid neutralizing capacity. And you could see that it's increasing from 1993 and on as well. And then Limekiln Lake clearly in the beginning of the 1990s had very, very low acid neutralizing capacity or alkalinity. So it was really threatened by acid rain. But from our data, we could see that that is increasing. So that's all really positive stuff. All right, so what did the 25-year report trends tell us? So there were no pH trends for a majority of study lakes. That's not really surprising. One of the best things was the increasing alkalinity. 81% of our study lakes showed an increase in alkalinity, and that's great news. It shows that you know, the effects of acid rain are starting to be reversed as such. It'll never really go away. Acid rain pretty much changed the watershed and landscape for years to come, but it is good news that our lakes now have more of an ability to buffer any acid rain that would be falling. All right, so another thing that we measure for, or that we analyze with these reports for the trophic state of our lakes. So essentially the trophic state is just the measurement of overall lake productivity. Lake productivity is essentially what's growing in a lake. And this is analyzed by measuring the transparency, chlorophyll A, and total phosphorus. All of those are indicators of how much can grow. Chlorophyll A is pretty much the major one because that's essentially just the measurement of how much algae or cyanobacteria would be in a water body. And of course, phosphorus is needed to make for algae to grow. So the more phosphorus, the more chlorophyll, and then probably the less transparent a lake would be. The graphic on the left was taken from the 25 lake report, and that just shows how all of these trends work. If you look at the long one where it says mesotrophic, if you could see it, it might be a little blurry. I do apologize for that. You could see how trophic state can change over time. And it's something that we're constantly looking at. And with this one, this is Seventh Lake in particular, it looks like, you know, it was pretty mesotrophic during the middle, and then towards the end of the study, it became oligotrophic. So it means it became less productive. All right, so productivity is naturally influenced by nutrient supply from the watershed, climate, and lake morphology. So just because your lake is maybe eutrophic or mesotrophic, it doesn't necessarily mean that something is polluting the watershed. Lakes will naturally age over time, but of course, human activities within a watershed can speed up the process. And that was that cultural eutrophication that we were talking about. So out of the 21 lakes monitored, 14 of those are mesotrophic, 2 of them were found to be eutrophic, and the remaining were oligotrophic. And there's a healthy mix between those in the Black River watershed, with 7th and 8th being oligotrophic. So those are the really deep, clear lakes that don't have a lot of productivity in them. All right, and then here are some of the trends that kind of go along with trophic state. So we found a decreasing phosphorus trend. 90% of the study lakes have a significant downward trend in phosphorus. This could be due to any number of things, but most likely, you know, fixing those septic systems, using fertilizers that weren't rich in phosphorus. There are many possibilities. Right, Kayla, you can move down. And then another one, which is pretty interesting, were the transparency trends. So this one is kind of so-so. It can directly be related to trophic status, but essentially it's a good thing. So we found that a majority of lakes in Hamilton County and in the Adirondacks in general have transparency that's decreasing. And through research, it's kind of been determined that this is due to an increase in dissolved organic carbons and is viewed as a sign of acid rain recovery. And it also could be due to the fact that there's increased precipitation from climate change. So it's nothing to really be too concerned about. And so the dissolved organic carbon can be washed in from the watershed, and that likes to soak up a lot of light. So you're not going to be able to see as far down into the watershed or into the lake. All right, so now we're going to talk about sodium chloride. I know we're going really fast. If anybody has any questions, please feel free to put them in the chat box and I could do my best to answer them afterwards. So we started testing for sodium and chloride in 2013 when we started to hear about road salt pollution. So it's kind of a newer threat to Adirondack waters, but really, you know, we've been salting our roads for a very, very long time. If you look at that wonderful graphic over on the right-hand side, all of the roads in red are state roads, and then the other ones are local and county roads. And down below, you'll see just how much salt is laid on our roads. Close to 200 tons or 200,000 tons of salt a year on our roads. And all of that salt needs to go somewhere. It doesn't disappear. So, you know, it infiltrates lakes by surface runoff as the plows drive by. They plow that sloppy, salty slush, pushes it to the shoulder where it melts and goes into streams or tributaries, and it's getting into groundwater as well now. So we analyze all of our water samples for sodium and chloride. You could go down, Caitlin. All right, and so what are the impacts of road salt pollution? There are so many resources and research papers available that are discussing the impacts. I'm sure you guys have it's all over the news in the Adirondacks and beyond. Some of the more important ones, though, are the water circulation impacts that was seen in Mirror Lake in 2017. There was a study done by Brendan Wiltsey and a few folks from the Adirondack Watershed Institute that found that the salty water building up in the hypolimni, and so the bottom water of a lake, was interfering with lake turnover. Another impact that could happen was the health of aquatic species. So lethal levels of salt would be rare, but sublethal levels can still impair the health and behavior of some species. So that would be after like a really large melting snow melt event, really salty water can rush into a stream. And if there's anything there, that can potentially impact that at the moment. And then of course, the road salt has been found to threaten our drinking water. With the groundwater infiltration, there's increased levels of chloride and sodium that are being found in well water. Dan Kelting from the AWI is doing great research on that right now as well. So those are the impacts of road salts as such. You could go down. So these are just a few sodium and chloride trends that we found. So we don't exactly have enough data to signify whether they're significant or not yet, only a few years. But as you can see, the Seventh Lake graph is a salted watershed. So that has 10.6 kilometers of state roads in it. And you could see how elevated the sodium and chloride levels are compared to an unsalted watershed, which is Limekiln Lake. So the levels that you're seeing in Limekiln Lake is what we would normally expect to see in an Adirondack lake. That doesn't have salted roads. So the difference there is pretty drastic, and everything that we're seeing is definitely showing that road salt is becoming quite prevalent throughout Hamilton County and beyond, is polluting our water. All right, you could go down, Caitlin. All right, so I know that was really quick, but the conclusions essentially, so what did we learn from the 25 years of data? We'll try to wrap up all of that stuff up there. You know, it was mostly positive. We have decreasing phosphorus and nitrogen trends, which means there's less algal blooms, fish kills. If people are taking care of their properties, they're not using that heavy phosphorus fertilizers, they're getting their septic systems checked. You know, that's a really good thing. We're seeing also that there's the recovery from the acid deposition. So with the increasing alkalinity trends and the decreasing transparency trends. And then the last thing that we've really learned from this was the water chemistry that's being influenced by salted roads and watersheds. And I believe the 25-year report found that 91% of the study lakes show a clear sign of road salt influence, which is huge. Right, you could go further. So that brings us down to what the benefits of our program are. So we have over 25 years of data, and this data can be available to anyone. You know, we're funded through the state, so all of this data belongs to all of you. We share data with many user groups such as lake associations, municipalities. We can share it with people who are doing research. So we're hoping that this data can help inform science policy and support research. And with all of this stuff, you know, the district itself offers many educational presentations and resources to Hamilton County residents and property owners regarding water quality. So if we start to see a problem within a lake, you know, we could start to put that outreach and education out there about the problem. So road salt, for instance, you know, now that that's becoming a problem, we could answer questions, do presentations about it to try to decrease that. And we think that's pretty neat that our data is showing that it's having a problem in Hamilton County. All right, you could go down. All right, so of course, none of this would be possible without the many people that have helped us. So we have lots of gratitude for our partners. Funding for our program comes from the New York State Environmental Protection Fund and the Finger Lakes Lake Ontario Watershed Protection Alliance. You know, we're really grateful for Hamilton County Board of Supervisors and our other committees that help support the work that we do. There's been multiple people over the years who have collected data for us. And, you know, the New York State Department of Environmental Conservation. And then, of course, a special thanks to the Adirondack Watershed Institute. Without their support and help and just writing and taking all of this data and turning into what it is, you know, we wouldn't be able to present on it. So we really appreciate their expertise and everything that they've done to help us with this. All right, and that's all. Questions? Thank you for listening. Sorry it was kind of crazy with not being able to share my screen.
You guys did amazing. You solved that problem on the fly. That was fantastic. Thank you. Thank you to both of you, Caitlin and Jamie, for solving that and for an awesome presentation. There are a couple of questions in the chat. Can you see them?
Sure. So is Hamilton County enforcing the septic testing regulation today? Unfortunately, I'm not sure if they are or not. That's really tricky. Some of our towns are starting to get local laws put in place again about making sure that all houses are septic tested before they get sold. And we're working with a few towns on starting a program for that. As far as countywide, I'm not sure. In the research that I did with all of our historical reports in the 1970s and 1980s, you know, they always had this septic program, and then for some reason they just stopped talking about it. It wasn't there anymore, and I'm not sure how that happened. I would like to dig more into it, though. I don't know if there was a funding issue or if they decided to let the overall towns take care of it. So yeah, I mean, there's no really easy answer to that. So some of them are, some of them are, I'm not really sure. And then can a town or village request that residences near lakes be tested? I believe they can. I'm not sure, Caitlin, do you have any more insight on that?
Yes, we have a Hamilton County town, the town of Arietta, that's currently going through the process of implementing a septic system law. And when property changes place, it will be required for the property owners to have their septic system inspected to make sure that it's up to par and not polluting lakes or streams, other water bodies. And the process for that, the town supervisor and the town council people are working together. They've hosted a number of public comment periods to elicit any concerns or items of support from the public. And they've also worked with our Soil and Water Conservation District. We have a district technician, Lenny Crute, who is interested in being a partner, conducting the septic system inspections. We're going to buy some equipment and really help the town to move this program forward. So it starts with the town supervisor and the council people drafting up a law. That law goes to public comment, and we have our fingers crossed that that law will be passed.
Excellent. Thank you, Caitlin. All right, I see one more question, and that's asking if there are any economical and environmentally friendly alternatives to sodium chloride for treating roads. That's another tricky answer as well. No matter what you're putting on a roadway, it's going to have some sort of impact, whether it's sand or beet juice or, you know, there's all of these things. There is a really great resource out there. I forget the name of it, but it goes through the best management practices for road salt. So I know there's lots of work being done with upgrading equipment, making sure that the plow truck drivers are not going out when it's unnecessary, pre-treating roads so the salt doesn't just bounce off. So basically at this point, from everything that I've read, just trying to reduce the amount of road salt that's being used and updating stuff. So for instance, having live edge plows that are, really scraping the ice off instead of having to throw a ton of additional salt on the top of it, that helps reduce the use of it. So, I mean, there are things that are being done. And like I said, there's tons of resources online. I think the one I'm thinking of is called the Roadmap to Reducing Salt or something like that, but they're readily available online. All right, anything else?
Are there any other questions for the folks from Herkimer County? You can drop them in the chat.
Jen, I had one question. There is a pamphlet, a Japanese knotweed pamphlet that I see that they put together, and I was wondering if they would be willing to share that format. Maybe somebody can customize that format for their own county to educate people about Japanese knotweed.
I am definitely willing to do that. Oh, sorry, guys. I am willing to do that. If someone told me where I should send that, maybe to Jennifer, and she could distribute it. I can do that after this whole thing is over.
Okay,
Or
great.
if you want to send that to me, I can get that to Nichelle or, yep. All
Thank
right.
you.
Sure. With that, I would like to thank Catherine, Bob, Caitlin, and Jamie for talking to us today about your work in the Black River Watershed. Again, Caitlin and Jamie, awesome job under pressure. Thank you very much. Thank you for always looking for opportunities to move all this important water quality work forward and for keeping all of the partners engaged and working together. Your passion for our shared natural resources is admirable, and it really shows in all you do. We have another webinar coming up next week. I hope you'll all join us for what would have been our keynote presentation on the early history of the Black River Watershed. Information about that is available on our website. I'll have this recording posted as soon as possible. And with that, thank you, everybody. I had a great time and I learned a lot.
Thanks.
Thank you, everybody. Good job.
Thank you.
Good job, everyone.
Bye-bye.
Bye-bye.